Hello, back live. Happy 5th. Hope you've all had a festive 4th of July. Pretty much just worked on some AI stuff yesterday and then called it an early night. We did do one cool thing though. Look at this. We got the drone flag. Go grab my chat. Stick it underneath the camera. So yeah, this is pretty cool. Like, maybe you've seen the drone light shows where all the drones are super coordinated and you're like, why do you need RL? The thing is, like, those drones kind of just have to go from point to point, and they're routed such that they don't really have to worry about collisions at all. Because you're just kind of like rotating an object for the most part, so nothing can collide. Whereas this, like, there's no actual path planning included. The drones kind of just have to figure out how to get there from whatever starting point without crashing into each other, and you can actually see them trying to like get out of each other's ways. Now, this is not perfect. You can see that there are still a few places where they're a bit off, but like this was like a 2-day demo, and this just works, and it trains in a couple of minutes. They can do a lot more than just this as well. That's not what we're going to be working on for the most part today, though. Today, the plan is going to be to work on my article. So we've had just, I think more than anything I've done, I've had people request educational materials. And, it's not the main thing I do. It's really not. Like, I didn't start these streams to teach people reinforcement learning, and it's actually not even my main objective now. See, my main objective is to advance the science, to advance the field, right? That's the whole shtick around here. But it's been pretty cool to see how many people have gotten into reinforcement learning because of Pufferlib. And a lot of those people have gone on to actually help us quite meaningfully in our research. So I think today I'm going to spend a little bit of time, a little bit back to that community, and put together a decent guide. Welcome, Majid. So this is where we are at the moment on the guide. We are at 2,200 words already. I do always get a little bit nervous when I write longer pieces of content like this, just because like very often longer stuff doesn't do as well. People have very short attention spans. But at the very least, this is going to end up being a very complete reference for a lot of people. So we finished yesterday the intro programming section. And we got pretty far through the intro ML section. So I think we'll finish the intro ML section, and then we'll actually start on the RL proper today. And we'll see how far I can get on this. And the reason I'm streaming the writing of this is so that people can give suggestions on things I'm doing. Try not to derail it too much, but obviously I do want feedback and suggestions. This is on X, but this is not published yet, Majid. I am working on this live. So you can see what I'm writing on my screen. There's not really a way to do this in the X formatter. Technically do a Google Doc thing, but it's really a lot easier to do it directly in this format, so I don't have to reformat the whole thing. I'm already gonna have to do this once for the website. So realistically, I'm not gonna be working on like jumping around sections too much, so you'll probably be able to just see a couple paragraphs on my screen and provide feedback on the thing I'm doing at the moment, which will be more helpful because like comments on like how to improve different sections all around, the screen is just going to distract me. I think you'd rather like get feedback on one section at a time. Okay, let's go through this because I forgot what the heck I wrote last night on this. And this is where we'll start. Becoming an effective researcher is actually easier than becoming a good programmer. This is bait, but I genuinely believe that this is true. Most researchers are bad programmers. That's not even controversial. Good programmers have a much easier time becoming good researchers than bad I don't know what I was smoking yesterday, but okay. I became a good researcher before I became a good programmer. I wish I'd put more time into becoming a good programmer first. This is all true. This is like the most provocative thing I can say while still being strictly true. Like, or strictly in accordance with what I believe, which is that's where I want to be. Okay, so this is true. This is the best resource that I know. It is not a hard course. It's a good minimum bar because if you can't do this course, you kind of just need to pick up a calculus textbook. And believe me, my math sucks, so that's not a high bar. I've been studying a little bit of quantum physics lately, so I've been trying to pick back up some math, but okay, so I still believe that this is true. Like, courses have very quickly diminishing returns, especially in ML. So, kind of take this course and you start reading papers. So these are the two tips that I came up with that are the most helpful for understanding how to read science. Understanding the process by which science is done, and then not like trusting. These are two very good things. I only want to do 3 to 5, I think, main tips for ML because I think that's really all you need. What of my own experience most useful thing I can give? Gotta be something about how I look to evaluate, like, how do you know what to work on, I think. The question, right? Do you have any questions, Majid? Like, specifically things on how to learn ML, things that are confusing. And Larry, hello, welcome. If you know ML, what were things that were confusing to you? Are learning or don't know ML, like, what are things that are, I mean, same question, right? What are things that are confusing? These have got to be two of the best things I can tell you. Can I join Discord? Yeah, I can jump in Discord. You're gonna have to allow me to like focus and write paragraphs when I need to, but we can absolutely discuss stuff in between. And that's open to everybody, by the way. It's just discord.gg/puffer. You're free to just jump in here. I think like I still remember what it was like learning ML. It was hard. But the thing is, the experience that I had is going to be even harder than the experience that new people have today because, like, the materials just sucked back then. Not only did the materials suck, but literally the technique sucked as well. I don't even remember if we were using Atom yet. How to choose problems. Or how I view progress, maybe. I don't know. I have a pretty unique way in which like, the way that I look at research and the way that I'm able to effectively pick what to work on, I think is pretty unique. It's not the way that most other researchers do it. Like, these two things, I think these are very good tips. These are tips that I think many researchers could give you, but probably would be too polite to, because you kind of have to shit on the scientific process and institutions. Hey, Majid. Majidir, welcome. I can't hear you. Say something.
Is it good now?
Yeah, you're just super quiet. Let me turn this up. Say something.
Yeah, I can hear you.
Okay, I can mostly hear you. You sound like you're super far away from a mic. Okay.
Let me see if I can.
Okay, let me turn you down first so that you don't blow out my eardrums.
Okay. Is it good now?
Little better? Yeah. Okay. I'll turn it up on my end and hopefully let me know if you're gonna like max your volume before you blow out my eardrums though. Okay. And I think Larry was here. I'm trying to remember which person Larry was. I think he was like wanting to start with Puffer and already was doing RL. I'm trying to remember. I don't know. You can jog my memory if you're still here. Um. Yeah. Do you have Magider? Do you have? I hope I'm saying your name right, not completely butchering it, by the way. But do you have
I
stuff?
mean, you can say me, Majid. Yeah.
Magic? Okay. Physics grad with a few projects. Right. Okay, physics grad. Yeah, I love when we have people in hard sciences. Because this is ultimately where we want to go with Puffer. Not RL. We have two physics grads around here. There's Tyler is in the Discord and who drops in around here is he's currently a physics postdoc. Yeah. We definitely want to do more stuff with hard science. Ultimately, where I want to go with Puffer is optimizing like complicated real world processes that just don't fit with LLMs and other of these big models. And where we can do like high perf sim and all that. I want to see if we can really push forward hard science and hard tech. LLM suck, yeah. And people don't really realize it. So that is my plan. And if you have ideas, I will be very happy to entertain them. Maggie, you wanted to share some of your experience with ML, you said? Got any ideas for me for this article?
Yeah, I think before that, I think if I gave some introduction about myself, like background that I have,
Sure.
You know, you know, like I'm coming from, the industry. I work for software development. It's been, 7, 8 years. I know programming well. I know different languages, Java, .NET, any web programming or backend programming. And I know that. So what happened, I have few problems but I actually don't know how can I solve that using, regular. I mean, we can solve a lot of things using, regular programming conditional way, right? But I was interested to learn AI, ML. I tried to learn a little bit of deep learning and some basic projects, but I was not kind of feeling well that probably this is not an uh, exact thing that I should learn. Then I found out RL, which is, I was super interested like how things will work, the fundamental things of RL. So, I tried. Maybe it's been like 4 or 5 months. I'm studying with RLlib, and
Hmm.
there are different libraries. But I was
Yeah,
kind
that's
of
not gonna be fun.
stuck at some point. Yeah, I'm not able to solve few specific problems. Even I cannot even run that on my machine. That's how frustrated I was.
Yeah.
I-
No, I'm
yeah.
aware. I had to deal with it for a while. Okay. Did you
For
do
some
something
reason,
like
even
231N? Did you do something like
uh
231N or like a general deep learning course? Or you just coming into RL just without anything in AI?
no, no, I know a little bit of how to build not that deep,
Like,
neural
could
network
you
and
write
other
a basic
things.
autograd?
Yes, yeah.
Okay. If you could write a basic autograd, then you have at least something. Have you read like at least some number of academic papers?
So I don't have like, yeah, I did couple of them, but I do not understand. Few of them are goes over my head.
Okay, yeah. So
You
that's
know,
okay. I got you. Now I know where you are from that. Um you do have to read papers in AI. It's not just for the researchers. Like if you're in AI, you have to read some papers, like at least some. And it is hard, and it gets easier. This is actually this right here is exactly intended to help with this because
but one thing that I feel about paper, for some reason, like, you know, I do read couple of papers, but I feel like it's, I mean, on paper, for some reason, researcher they don't want to use simple words. I mean,
this
if
is
you use
yes.
complicated word, that means your paper is great.
Okay,
If it is not, if you use simple word, that means it's a bullshit.
okay. Read. Have you read this paragraph?
Oh, I mean the X. What's that
The
name?
paragraph that is on
That
my
name?
screen right now. Have you read this paragraph? Read this paragraph and see.
Uh,
Ex- What? Excretion. This is this is an article, Larry.
yeah. So,
Does this paragraph help, Ajay? Tweet excretion.
I mean,
It's an article, not a
yeah, it's
tweet.
helped to yeah, it's helped to kind of how should I prepare myself when I kind of approach a paper.
So this article is very dense. Like it's not hard to read, but like everything in this article, like it is meant to be very dense. So like if you read this paragraph a couple times and you really think about this, a lot of things in science will be a lot clearer, including how to read papers.
Yeah, no, that's actually true. I think
Like
true for everybody. It's not just wants to learn RL. It's kind of general. It's like
this is a general
somebody
comment on
wanting.
science, but it's particularly true in AI. So
Right.
it is literally the case that like yes, very often a lot of these papers are way simpler than they appear, and that is by design. This is why it is by design, and understanding that should help you figure out understanding that should help you.
Yeah, so I was even when I open any paper, you know, their ideal is good, but when I go, beyond abstract, I was kind of a lost on every time.
Takes time.
100%.
Like if you look at this for instance, this is the original ImageNet paper. Let's do like ResNet rated GPU time. Literally, that is what happens. That's actually in a nutshell why RL is such a mess. So like this is the ResNet paper. This paper could probably be like 2 pages. This is like one of the most fundamental papers. But pretty much this is true of a lot of things. Where like the key idea of this is a few sentences and then like maybe like a few pages of experiments and details. Instead, this is an 8-page, very dense paper with an additional 3 pages of appendices. We did some dot products and skip connections. Yeah. This is why I
Yeah,
no
then
longer
my
write papers, by the way. Because writing papers in this style is just soul-crushingly painful to me. When I can write way more casually, way more succinctly, and way more precisely, like this. Okay. Let me think if there's a sentence or two I can add to this that would help you even better.
so let me share a couple of experience. Like when I go through any RL paper,
Hmm?
like nobody told me like how to approach that paper. What should our expectation when I read that paper? And the paper you mentioned is like those are all pre-selected, or for a start who want to start RL, they, they shouldn't do all the paper. They should look some sort of selective paper, and we should kind of have
I
a
will give you a list for reinforcement
uh,
learning.
yeah, for summary and things like do not expect other than these things from this paper. Just understand the fundamentals, understand the implementation. That's it. Like to
So the
set a
papers that I
boundary, how to
suggest,
approach.
because it is such a short list, um, you actually probably want to understand most of the things in the papers that I suggest because I don't tend to suggest bullshit papers that are like super padded. Um, but it's a very short list. Like for instance, the OpenAI 5 paper, the Dota paper is really long, but like there's a huge amount of value in understanding that paper. Like I would take that paper over like a randomly selected set of 100 RL papers, say all of which have a decent number of citations. I still take the OpenAI 5 paper.
Right. And so what approach I took on that time when I don't understand. So what I did, I basically upload that paper into Google Notebook, and that's kind of simplified me the overall expectation and the
So
Uh,
you can do
know.
that, but like Google Notebook, I assume is LLM. Google Notebook LLM. Yeah. So language models are really stupid, is the thing. And you actually do need to, like, it's hard, but you do need to actually learn how to extract truth out of papers. It is a very important skill. It is very hard. I remember this. I started doing this when I was 16, and let me tell you, it was a hell of a lot harder back then. But you can learn it.
Okay.
This
I
is
mean, I
why,
shouldn't
but this
focus
is why, like,
any
when
other
I said how
projects.
to, the point is, like, when I give people this RL guide, I drip feed it to you. So, like, you don't have to do this before you do anything in reinforcement learning, right? It is something that you do need to do as you improve. I can get people started without reading any papers, but you do need to do this to
But yeah,
improve
to
over
become a
time.
master, yeah, we need to have to read paper 100%.
It is mandatory. It is actually mandatory. Get this from Larry.
To the block at that position.
Oh yeah, I forgot 3 blue, 1 brown. I actually haven't seen any of his videos, really. People speak very highly of them. Yeah, that's a very good animation. I mean, it's cool looking, at least.
This is kind of a explainer video, I guess.
Yeah, and like this guy is not like a shill. This guy is like actually a mathematician who usually gets stuff right. I don't know. I don't really watch like a lot of technical content except courses. I don't really watch a lot of technical content in my spare time. I most except for like course material. Those I actually do. How bad LM's at storing facts? Oh, yeah. It's it's not exactly that reason, Larry. It's the fact that like distilling uh actually distilling papers into what matters, what is true, what is probably true, what makes sense but may or may not be true. Like that is a skill. And LLMs are bad at it. And if LLMs were good at it, then they could probably do research on their own effectively.
Yeah, I
They
think
can't.
yeah, Apple just published a paper like about LLMs, and they say LLMs is about like illusion, the model.
Yeah, so basically here's the thing, and I will say this once because it's like we banned this spot. Like, regardless of your views on how fast you think LLMs will improve, it's kind of stupid to let it influence how you learn things in any way, shape, or form. Because, like, if you think, oh, the LLM is going to be able to distill the paper and, like, suggest the topics. Oh, the LLM is going to be able to code the experiments. Oh, the LLM is going to be able to, like, validate results. Okay, you're just saying that you think AGI is happening next year and that all human talent will be irrelevant. So, like, at that point, you may as well not be doing any of this. Go lie on a beach somewhere, right? So, like, if you actually think that your agency matters at all, you should still learn these things. And you should learn them at a deep level. Because if you don't learn them at a deep level, and you just learn things surface level, then you're not going to be able to provide any value compared to people who actually do learn these things correctly. This is how I view a lot of things. Hey, Almas. Welcome. Okay. Is there something I can add on this? It's difficult to distill that discussion into a couple of sentences. Well, I think I can make this part of the next section. I think is going to be what do I title this? It's kind of the way that I view research or the way that I choose problems or how to interpret research, I guess. How to interpret research. Do you have any resources, as you said? If someone's going to understand levels, that is not true, almost, because MIT and Stanford. I did my undergrad at Stanford and I did my PhD at MIT, and both of them have courses available, full-length courses available for free online that are the exact same courses that I took. And I'm going to let you in on a little secret. Coursework is like less than 10% of my background of like what actually makes me able to do what I do. It's important, and learning the fundamentals quickly does give you a leg up, but it's like literally 10%. Your time you have to put in is non-negotiable. It's true. Now, Larry, I do think that like we could substantially bring down the time that is required to learn a lot of these things. It's still going to take time and effort, but like for instance, I probably could have shaved 5 years of like 5 blunder years of terrible programming off if like I actually had somebody to discuss things with who was actually good at what they did. Programming is terribly taught. You're taught to solve problems in just about the worst way imaginable, and it gets ingrained very quickly. And you actually end up having to spend years unlearning stuff. That's my perspective. Like, over object-oriented everything is awful. Awful, awful, awful. Literally one screw up in my systems course. One screw up in my systems course prevented me from touching systems dev for almost a decade. You know what that screw up was? They didn't tell us what an address sanitizer was, or even that they existed. Writing C without an address sanitizer sucks, and it really put me off of low-level programming in general. The rest of the courses actually were very, very bad. Stanford's systems courses are terrible. But like that in particular was, I think, the worst screw-up of all of them. No, Russians, since I'm from past Soviet country, is a good source about ML and deep. Yandex, also working with Best University. Well, if it's in Russian, then that's not going to help too much of my audience. But if you can do that, then yeah, good for you.
No, one thing I also have, like, I also face some problem because, when someone try to learn RL or any particular field like AI, deep learning, or data science, or any other fields, basically we think, if I learn, what I'll become. Right? Let's say I'm investing 2, 3 years, 4 years into particular technology or particular career, what I'll become next. So I think for specific to RL, we don't have that kind of a vision, in particularly for a beginner. Like, if I know you are trying to learn RL, but learning RL, what you can do,
What you can do
except
with RL?
without playing games. Yeah, I mean, most of the tutorial or blogs, everybody talks about the games, but nobody talks about the real world problem.
Yeah,
I think
so
that is also one of the main reason that people are kind of unsure, like they are not confident, to be honest.
yeah, I need to motivate this stuff, to be fair. And also, Almas, we do have right here this quick start guide. This thing is littered with references. I'm working on it. The document I'm working on is a sequel to this, but all of this is still up to date. It's just shorter than the thing I'm making now. This is on puffer.ai. It's on the blog. So yeah, the thing is that like reinforcement learning has been applied in a few different very interesting use cases, right? Outside of games. We use games a lot because they're interpretable in research, but like RL is also just a less mature area of AI in general than vision or language processing, right? So it's like, what if you understand the tech, there are things about it that very clearly make it seem like this is going to be something useful down the line. But a lot of the work in RL, it's like there aren't just like applied RL jobs like there are applied vision jobs, right? Like technically there are a few jobs that say that they're applied RL, but they mostly don't work. And that's just because it's a less mature area. So the bet that I have on RL, right, is because very clearly it can solve hard problems, and we have seen the pace of progress pick up in the last year with all of the stuff I'm doing with Puffer, that this is going to be a very widely applicable area, and it's going to be applicable mostly to a lot of just unintuitive optimization processes that are scattered all throughout different industries. So it's going to have very broad reaching effects. Not going to be like a chatbot that you just ask stuff. It's going to be like embedded into a lot of hard tech. That is
Right.
is my view on it. But
If
like it's not here now because the thing is it's not as mature area, right? You're looking at a branch that is mostly active research that is being used by like largely technical companies that have their own scientists, right?
and
Yeah, there's
if
fusion.
we talk about like future opportunities, like
Well,
the other,
if you learn deep learning, like how long do you think it would take me to go be like as good at language model work as I am now at RL? It would take me a few months. It's all the same,
Mhm.
right? I
Yeah,
can work in any area of deep learning that I like. It will take me a few months to get up to speed.
exactly. And probably, so what make me come into RL, in particularly why I choose, if I talk about myself, why I prefer other industry compared to, why I choose basically RL. Like if people are already saying this, up until till now, every real world application that we have, you know, maybe 90% or 97% or 99%, they are all rule based application, not like you know AI driven or general purpose application. If we think about when it comes to general purpose, then comes into RL fundamental, because in real world that application needs to adapt and adapt such a way so that it can you know be in that environment fundamentally. So I think in next 5-10 years there will be huge opportunity
Yeah.
for RL, what
Well,
we're
another
seeing right
big
now
thing
as
is
a
just like
data science and other field.
it's an area of deep learning that one teaches you a lot of technical skills, and two, you can actually do it at home. Like you can't go train GPT-4 at home. It's just not going to happen. Alma says, oh, wait, by the way, it's interesting what PC you're using. I see you have Linux. What about specs? So behind me, I have like a dozen different PCs sitting on the racks. The one that I have right here is just it's a high-end main gear box with a 4090 in it. If you just want something for reinforcement learning, you need to get like something that has a good GPU of some variety. It doesn't need to have a huge amount of memory. 4090s are really nice. I don't know how fast a 5080 is by comparison, but some good chip. And then you also want to ideally get a good multi-core CPU. Like, I have a 9950X. I think that's the best desktop chip you can get at the moment for this. The Intel chips I've had a bunch of problems with, and they're architecturally a little bit wonky, but they still work. But yeah, like, ideally you want to get like a 16-core chip. It's not free, right? Like, it's just a heck of a lot cheaper than everything else. You can rent stuff, like if you go on like Vast, you can rent 4090s for 34 cents an hour, sometimes lower. I have one 5090. There's one of the machines back there that's a test machine that's a 5090. It's substantially faster for some problems and not all that much faster than a 4090 for others. I was gonna buy more, and I think I still am, but I just bought 2 tiny boxes, so that's plus 12 4090s. We now have a total of 20 4090s for Puffer. Do you think about Finance World? Bots will alter the quants. I do a little bit of work in finance that I can't really talk any details about. When do you think? And there already are bots, like, everywhere in finance, right? Just a question of, like, at what scale and such. I would hope it's not just people, like, letting LLMs run trades on the market, though. That's probably going to just lose a ton of money. Okay, I gotta actually write on this, right? The point of streaming this is so that we discuss this and so that I write it effectively. There are definitely people doing that, yeah, but there are people doing all sorts of stupid things. I hate the idea of any human effort being wasted on fan ads. Yeah, like, there are way more interesting problems, I agree. I would like, to solve disease and superconductivity and material science, all sorts of things. Let's add right here. Let me see how I want to frame this, though. I've sort of been thinking about this while I've been chatting. I don't want to say research taste because it's like the massive midwit topic on X at the moment. Because it's not taste. That's not what it is. Not a good word for it. It's building intuition about research, what it is. Build intuition about research, yeah. let's keep going from here. Thank you. No, you're good. It's just like typos that happen when editing, right? Like you changed the part of a sentence, and now something later on that was plural becomes singular, etc., etc.
Oh, I have a pretty dumb question.
Yep.
So when should I mean, on which stage I should see papers? The beginning or
Um,
after
you should
reading
probably
something
start
about
reading
how
them
it works?
like you should have read a few papers by the time that you finish something of the level of CS231N, and then pretty much as you are trying to improve methods or as you are trying to improve your understanding of any specific area, you should be reading a few papers over time. Um, it's a lot earlier than you think, I would say. Like literally there were 0 courses in deep learning when I started. So my first experience with deep learning at the age of 16 was just reading papers. I had like basic, I think I had like basic single variable calculus and linear algebra, and that was it. That's all I knew. and like basic programming.
Which year it is? It was
What?
which year it was? Like
I was like 16. That's halfway through high school.
2016?
Oh, which year was this? No, this would
Yeah.
have been like probably 2013 or 14.
Oh, that's pretty. Yeah.
Yeah, I've been doing this a while. How long are you streaming for? I'm gonna go get stuck into Puffer and try out the environments. Probably until a bit before 6. I'm going to dinner with my family for a 4th of July thing. Except a 5th of July thing, just the day after for some reason. I need to make this paragraph good. This is not. I don't like the way that this is going right at the moment.
Like, can we like before going into like more details, can we kind of generate like the steps, step by step, you know, high level category? Let's say, doing the course that you mentioned is, let's say, for one steps. Second is you have to read paper. Second
Yeah.
step. What's the third?
What's the third?
Yeah. Let's say, yeah, third is, pick a easy to understandable
That's it. There are
framework
no more
like
steps.
properly.
For AI in general, that's it. There are no more steps. Like, you do your intro stuff, you start reading papers and building things, and you keep reading papers and building things forever. That's it. There's no like magic third thing. Now, for reinforcement learning specifically, right? Like, if you want like more details on the specific area of RL, then yes, that's going to be the other portion of the article. I want to finish the intro portion first, though. I should be able to do quite quickly if I just like. It's only a couple more paragraphs. I just actually have to.
Okay, let me write my question to you and then probably can validate those to the
Okay, so I don't like this paragraph a ton. I think that this is not telling people enough. This is like a very important topic. I think it's fair to say, that this is a combination of validation, of validating results and pattern matching, right? Also some fundamentals. Knowledge of fundamentals, pattern matching, and validation. Can't wait to read the whole thing. So much good stuff in there. Yeah, I'm working on it, Major.
Um, I have made like 15 questions to you.
15 questions.
Yeah.
Did you write up a doc or something?
Yeah, let me share the link to
You can link me the doc.
Discord.
Let me at least get this paragraph done.
No, no, you can write, you
Yeah,
can see I have those questions and I want
okay,
to know
here. Let
how I
me
can
see. If
solve
they're
those.
relevant, I'll look at them now, and if not, I'll look at them after this paragraph.
Okay, you can I'll post that into Discord in general.
Where did you link these? In general? Okay, yeah. So you're this is all RL specific. So let me finish this first. We've asked for this a lot. Actually, I depending on how long this gets, I could release it as 2 articles. That might be better. Playing Half-Life. This is like an important point. Like literally, if you have too much respect for the scientific process, you cannot be an effective researcher because you will simply assume that things are true because they're published when they're not. All these messages. My mother's gram reels of Weddle seal. That's what the scientific method is. So it depends, because here's the thing, Larry, right? Like, there's a peer review process, right? Yes, the scientific method itself is about asking questions of things. But the thing is, like, if that's all it is, then like why is there a peer review process, right? Why, like, the point of the peer review process is to ascertain that the thing being submitted for publication is actually correct, which then creates this impression that if something is published, it's probably correct, and it's not. See? So yeah, trust the science is the least scientific thing you can possibly say. But the thing is, the institutions are set up in such a way that it suggests that publications like have already been reviewed by people smarter than you, especially when you're in a new area, right? Like, oh, this has already been reviewed by experts in this area. No, man, it's been like leafed through by some overworked grad student who's like writing some basically random comments and calling it a day. Yeah, trust the science is so bad, yes. Fundamentally not how science works. What are you sipping on? Uh, a seltzer that is flat because apparently it was from yesterday, which is why I made a face. I'll get more coffee in a second. I gotta finish this paragraph and then my reward is more coffee. Seven p.m. Scotland. Is 1 p.m. here. Terrible. Yeah. And then they get published in Nature. And you go, oh wow, what a great thing. Actually, you know what we're gonna do? I know what we're gonna do. There's way more out there than Puffer and RLib. Obvious ablation. You forgot about the page limits. There are usually appendices for that. I honestly, I don't think that people drop ablations for page limits as much as they drop them for time and GPU constraints. That you'd hate it. Why am I laughing? Because of this. It is kind of like, I don't know. Like, if you think about actually doing RL research, that guy, you'd actually be kind of crazy to use anything else. Like, I'm not talking about LLMs, like core RL research. You'd be kind of crazy to use anything else just because of the speed difference alone. Here's don't look at the appendices. Yeah. They're actually explicitly not required to look at the appendices most of the time. Conference has appendices. Most of them do, I think, at this point. Most of them do have the appendices. It does depend. But, like, if you didn't have to write that paper the way that academic papers are supposed to be written, you actually tried to, like, you could have fit a lot of that stuff in. Like, academic writing is super bloated and dry and boring. Or robotics. Okay, to be fair, I'm probably mostly just thinking of NeurIPS because that's the big one that everyone submits to. My website. Yeah, so that, I mean, that's more like blog post walkthrough. I think if you wanted to just, like, put, like, the core ablations and, like, motivate, like, you could probably fit a lot of it. Alright, SPY. That's absolutely you. Totally an alt. Honestly, I know you're only partially joking there. If Pokemon just ran 1,000 times faster, you wouldn't have that problem. That simple, right? Ready to put my Delph 20 laptops graphics to work. It will actually let you at least run Pong with that. just found the full RL iceberg. Yeah, watch that video. That one took a lot of work and didn't get very much attention. I think it's a high quality thing. Highest leverage unskilled engineer AI research is vibe coding RL environments. Where? Dude? I mean, it would be a snarky retweet if anything, because it's an incredibly stupid take. Welcome, SA. The highest leverage thing you can do is actually learn to code. And then actually, like, help us build some RL environments. Turn Justice. Is this like, who is this? Is this somebody I want to even tweet? Oh, these dudes. Freaking Prime, man. They have some good stuff and they have some abysmally stupid takes. Do that. Where's the intro thing on puffer.ai? It's in the blog. I gotta fix a couple posts in here, but see, there's a quick start guide. RPO themselves into oblivion. I thought you'd enjoy the take. I don't know why. I mean, it's like literally all of my content is about actually understanding things correctly. Let me make something clear. If you're typing things if you're just basically typing shit into whatever LLM in a loop without actually understanding what's going on, you have zero marginal value. Zero. Utterly worthless. The highest leverage thing unskilled engineers can do is page. I mean, look. The highest leverage thing you can do for RL is kind of just to mail me some gold bars. And I will help solve your problems. I will help solve your problems. Like, I'm literally making it as easy as possible for new people to get good at reinforcement learning. And we have a few people who have in Puffer, but like the mainstream is still like a catastrophic screw up. So for as long as people keep doing it wrong, that's kind of the best thing you can do to get me to do it. And for reference, we have set Soda on like multiple different clients projects for 10K a month. So there you go. Also start Pufferlib. It helps us out a ton. This is like a really good piece of advice, but it feels generic, and it doesn't feel like the strongest thing I can tell people. Why is XChat broken? If you link stuff, it'll break. If you spam messages, it'll break. If you look at it the wrong way, it'll break. It's not stop thinking, just do it. Sounds like a shippable product. The product that we have is service contracts. As well as, I mean, deliverables contracts, to be fair. But yeah, all our stuff is free, and companies can hire us to help with their reinforcement learning efforts, or to solve, like, problems that clearly are RL problems for them. They're larger, though. Fixed deliverables. Why don't I like this paragraph? It's very good advice, but it feels generic. But something of this form, I think, is needed. If I want to, like, think of the top 3 things that I can tell people on learning ML in general, this is a good one. I think it's missing the path to both are kind of the same. But when you say learning research, how do you do it? Even gold bars. A male. It's not quite that though, that guy. It's not just like it's not just put in the reps. I'm trying to provide perspective on how to approach that process to make it faster and make more sense. RL Alchemy. Turn money into gold is money though. About your anecdotal experience instead of some generic story. There's only so much I can flame existing researchers, though. Because basically, the evidence that I would have to provide here would basically be like how I found out that X and Y researchers are frauds. RLDM, no. When do you realize you developed intuition? I mean, it was a slow, continual process, right? From the time I started reading papers. Literally over a decade. You ever have an aha moment? In reading papers, not really. RL having its own conference. I mean, NeurIPS is massive, so it's fine to have a smaller conference. I will be going to RLC. I like this. Training LLMs depend a lot on RL. Now they do, apparently. It like use a lot of RL in a specific stage. Yeah, mostly at the end. Don't be afraid to be a contrarian, but you better know what I'm doing. I'm being as contrarian as possible without saying X, Y, and Z specific incredibly well-respected researchers are frauds. So see, the problem is that with doing that is that they're very damn good at it. Yeah. And that's not even a useful thing, because that's not what I'm trying to tell you, right? Research comes from contrarians. I mean, I could write about the way that I approach problems like that. It is pretty much, I just, like, look for the thing that nobody else is doing. But that's not how to learn ML, right? When do you see RL problem and determine it's not possible with current RL research? I mean, some problems are just not formatted well for RL, right? You can very, very easily construct problems that are trivial for humans, but like virtually impossible for reinforcement learning. Okay? So like, literally all you'd have to do is take an image that says, like, to solve this problem, enter the following code, and put a code, and then the action is entering the code. You're not going to solve it with RL ever. Mostly problems that rely on like baked-in priors that are not learnable within an environment itself. How hard would it be to pre-train an LLM with only RL? Impossible for the exact same reason. Just take the information theory perspective on it, right? You're getting a bit of information per sequence instead of like number of bits information of bits per sequence. Anyone here play chess? We have somebody in the Discord trying to get us a chess environment for RL. That's actually something that I wanted to do, is see like how well you can do at chess with just RL and no search. RLable but too damn complicated. Usually it's because there's some form of outside knowledge. You can see my DMs. Oh, is this Turing machine stuff? Reward is scarce and requires complex decisions. So it's the thing with neural MMO, right? Is like a human doesn't have to actually have played it a bunch to know how to play it, because the visual information is set up to be very obvious, right? You have to think about how you would learn the problem tabula rasa. How would you learn the problem from scratch? Okay, I'm spending way too long on this intro section, and I want this to be done. So let me finish this paragraph. Okay. Let's just do it this way. Into lunch. See you after. this. Actually, I can be more specific than this. Pulse is too simple to learn multiplication. How often do you see? Big policy also not that often. We do have complicated problems where it makes a difference. I'm gonna have to look more at your environment in detail. I haven't been able to do so yet though, because you actually have a fairly like sophisticated environment, and it's gonna actually take me a fair bit of time to go through and like validate the method. Okay. Let me see how I like this. So I also don't know how your data is being presented or normalized or anything like that. Like, if you actually trace through what has to be done to solve your task and the rewards given, does it seem like something that could be learned via curriculum or exploration? Okay. Let's see if there's anything in here. Validation was close to 70. Well, then that's... I mean, then that tells you something, right? If you supervise the problem, and you're getting about the same result, that should tell you something. Been following you and watching streams for 3 months now. Stealth watching, working my way up. ML, haven't reached RL yet. And it's coded. Work ethic is admirable. Oh man, this is considered lazy for me this week. For these streams. You got it, man. I'll be releasing this guide soon for beginners. You should absolutely do some ML fundamentals first. As in the guide here, it's like one course worth of information, I think. Like one course worth of information in fundamentals of ML, and then you can do RL. We've literally had brand new programmers do like start straight with reinforcement learning though. So if that motivates you, that's cool too. I generally suggest new people spend 20% of their time on formal content and like 80% of their time building stuff to learn. Puffer, Pokemon on Puffer 3, trying to see SPS, fix compile, info and state handler. Cool. With or without... Don't say what? Don't say that. What? What are you referring to, doctor? And 1 second, let me use the restroom real quick. Lazy week is more... Oh man, it's... Yeah, if I work like a 40 or a 50-hour week, that's like pretty lazy. When I'm like actually well rested and have like a cool project to work on, you know, I can pull like an 80 or a 90 and basically you can just solve like ridiculous things in like 1 week, one productive week. But you can't do it constantly. Can't do it constantly. Ironically, I'm least productive for conference things. Like I gotta spend a day cleaning up and my camera ready for RLC. I'll probably just do it on stream. I don't care. And it's like I don't want to do it. Like mentally, I just can't force myself to do boring stuff. $500 to 1K lower. Yeah, so there's one thing I did do, that guy. We did somewhat change the way vectorization works a bit. Might want to like triple buffer instead of double buffer if you're doing that. multiplication is a convolution of one multi-digit number over the digit dimension. Is it? Somebody will have to explain this because I don't think it is. With the digit dimension. I don't think it is. I don't know. Papers like RL graph. Trying to get the computational graph. I haven't seen that. Point of this? Huh? What's the point of this? Okay, just based on this, I can tell you this is slow as hell. So, if the point of this is to like... The heck? Yeah, I don't know. Digit multiplication. Raising its convolution using FFTs. Well, you can't, then you have to learn the FFT, right? Okay, let me go through this and see how I like this as a intro to ML. The programming one is way longer. But I think honestly, like, how much more advice do I have than this for ML? This is mostly it, man. Puffer is 10% slow. So that guy, you might have to adjust the vectorization a little bit, because, well, I mean, like the vectorization settings, because basically, if it's assuming it's the environment that is slower, which you should time, it's the thing is that we were doing like full env pool before, and now we're basically doing the zero copy mode by default, where you get blocks. You go like one block, then the next block, then the next block. So it's going to be better if you do like triple buffered instead of double buffered, for instance, for this setting. And also keep in mind that the learning should be more efficient, because you're no longer like wasting time on low value samples and like screwing up your policy with low value samples. It should learn better. We haven't figured out real-time training yet. It's not that we haven't figured out real-time training, it's that it fundamentally doesn't make sense. Like, at least not from like a newly instantiated model. It doesn't make sense. You're doing trajectory filtering in default pufferL. Yes, we are doing trajectory filtering by default. We're doing puffer advantage by default. We're doing muon by default. All the advancements are just in there, like by default for you to use. Let's go through this and see if this makes sense. Still using Atom? Stop that shit. Muon's better. You're trolling if you're using Atom. You're straight trolling. That was like one of the biggest advancements. hidden config still all over the place? What do you mean hidden config still all over the place? There's like one config, right? Like the default config just has all the parameters, and dash dash help will list all of them. I have to read your code to understand the config. By read the code, do you mean read the config file, or like the names are not explicit enough? I haven't ported to your config style. I'm still using my own. I had to dig through Puffer to understand the Atom config. Okay, so you do have to read the ini files. And, I mean, you are sort of meant to just use the ini files. You can load stuff into a dictionary if you really want to, but then that's kind of like on you. Again, like, are you looking for more than a list of names? Because like the Atom parameters are like Atom beta 1, Atom beta 2, Atom epsilon, or whatever, right? And they are listed. You don't have to read the code, right? Like, if you just run dash dash help, it will list them for you in a way that is always up to date and that can't get out of sync. Exactly what I'm looking for. I'm not using your version of main. I need my modified personal trainer. Okay, so when you pip install it, you should still get the Pufferl trainer, and that help will still tell you what's in there. You can just run like puffer train, puffer breakout, for instance. Dash dash help. Why do real life when there's a star? I must have missed some things. I come from neuroscience background, and real-time learning sounds like a necessity actually training like the brain. So, okay, let me explain this real quick. So the reason this doesn't make sense is that the human brain is not an untrained neural network, right? The human brain has a ton of priors baked in, and a heck of a lot more of them that you get, like general priors that you get early in development, right? So when you sit down to try to play Breakout, for instance, you already know how to play the game without having ever played it. It's obvious. It's designed to be intuitive and obvious. Not obvious or intuitive to the agent. So if you want a better analog that makes it obvious that real-time learning is not possible, we can screw up all the assets and like make a total mess out of the data. And heck, we don't even have to present it in pixels. We can just present it to you as a block of numbers. And then you try to play the game. That's how the RL agent sees it. Making more progress with ML than neuroscience. Yeah. Turns out it's nice when you can actually like fully observe the system you're working with. Okay, I think that this is like a good. This is a lot of good advice here. I don't know the extent to which people will be able to internalize it. Because, like, appreciating this stuff requires just spending a bunch of time in research. But I think that this will help. I think that if I have 3 paragraphs, basically, that all resolve around the idea of actually, let's just do this. Or else that it's modeled after the way the brain works. In general, you should assume that anything in ML that is modeled off of the way the brain works is very, very loosely so, and it's mostly modeled off of empirical results. Okay, I think I'm happy with these paragraphs. I think that this can be don't trust. I guess look for errors about research. I think just saying look for errors. All I have to do is swap this sentence down to let me see how this paragraph works now. And if so, I think we can move on to the rest of this. Okay, we reply to one message. Let me see what I missed here. Tactics for strategy for goal. On bio-inspired agents. BioML has existed way before MLML. Yeah. I just finished training. Gonna do some evals. Enjoy the stream. Thanks for great. Yeah, thanks for dropping by. Oh, hey, we have a fair few people watching this. So I'm gonna start on the RL specific portion of this in just a second here. So this is what, 10 pages ish? Probably 9 with the notes at the bottom. No, like 10 pages. Okay, so we've got like a 10-page article. And it's page or two on the intro. Maybe six, no, 5 or 6 on programming. Then it's really only like 2 or 3 pages on ML. But I think that this is the information I want to present. I think pretty much of everything, this is probably the most valuable piece of information that I could give myself. Because, like, I think when I started research, I think that I started thinking about, like, okay, you know, what is here? Okay, these are the papers that have been done. This is the stuff that's been done. Let me pattern match and figure out what I can do based on this. But I didn't take into account that a lot of the work is just wrong. So you can't really make progress when you hold in your head many mutually incompatible results without realizing it. So I think that this is a fundamentally better way of approaching research. This would have been useful to me. Hang on, let me go check on one thing. My parents are at the window for some reason. They're visiting. I don't know what they're doing. I'll be right back. Walk around a minute because I just wrote a whole bunch of stuff, and then we will start on the RL guide and any feedback you guys have, any stuff that you want to see included, please write it all down, comment it here, and then this is the reason I'm streaming this, is so I can get feedback on what you guys want to see and what questions you have. All right. Time to write the RL section. I want a puffer plushie. You and me both. We can get merch once we get, I don't know, 9 figures of revenue or some whatever. If the puffer is successful, we can make puffer plushies. Let's go grab all the content from the RL guide. I'm going to do a little bit of thinking out loud on this. So, there are kind of two parts to this, right? Like this type of thing, this is the ultra practical. The like ultra practical version of what I could cover here. How do I implement an environment? Signing rewards is like fair. Networks, how to tune it. Bug hunting. Benchmarks. Let me look at my existing quick start guide as a reference. See where I want to depart from there. So I do what is RL? I covered like a bunch of common terms. I kind of just shotgun all the terms at you. And I give these like pithy, this is how to understand this terms. Perspective. Man, this is actually a really good guide to try to beat. People want more than this, though, so let me think. Think exactly how to do this. I mean, if I think about it, I kind of just wrote something this style for programming in ML, didn't I? Like, that piece that I wrote complements this piece. Okay. The bar is higher than I thought. I set my own bar pretty high. I have to understand better, I think, where people are getting confused and what the limitations are. what have I given people here? I've given people common terms and how to think about them. A lot of general perspective that's very valuable, but it's going to be a lot to process for newcomers. And then I have some general tricks. It's the fact that this is not threaded cleanly enough into like actually showing you how to build stuff, right? So I have this quick start guide and I have the docs. And there's a gap between those two things. Really what I've done here, right? And it makes sense that I would do this because I wrote the other one. So like this is the style which I write stuff. This could be an ML quick start. The programming quick start. Okay, so if I think of what I've written so far as just like terms, tips, my best general advice, and then I think of the docs as taking you through how to build stuff. The gap between those two things. Yeah, like on one hand, you have a relatively simple tutorial that shows you how to build something. A new area. And on the other hand, you have a lot of really good general advice for the same area. A lot of really good general advice for this area. But then you don't really know how to, having built a simple thing, how do you use all this advice to do much more complicated stuff? How do you do that? there anything close to comparable? I think people want do this, do this, do this, do this, do this. Is that what people want? They kind of want a syllabus, I guess. Makes sense. Learning how to, like, I can't really assume that people just know how to teach themselves things, right? That is also, that itself is a very difficult to learn skill. We're not writing a blog on how to teach yourself things. That's too meta. I mean, the best, one of the best talks I've ever seen was on, it was on game design. It was on how to build tutorials. And it was just a one sentence explanation. It's teach gradually through experience. It. Teach gradually through experience. Did he get that from somewhere? Stuff like this needs to exist because some of this I can't teach you gradually through experience because you don't really need to, like, you shouldn't really experience it. You kind of just need to know that it exists. Other things I can teach you experience here. I can definitely make more concrete, like the level of projects and order you should take them on. that's not, I don't think that's enough. Because the thing is, like, this is all this stuff is like supporting knowledge around fundamentals. I kind of want to do like my own minimal fundamentals. Reading a blog is not experience, is the problem. I could do thing, implement this, thing, implement this, thing, implement this. The problem is a lot of these things are like, I can't do PPO, go implement PPO, right? Like, okay, see you in a month. I didn't think it would be this difficult, actually. I kind of figured that I would come back to this and it would just be like kind of mediocre. This is really good content. It's the presentation of the content. I think that's a problem. I'm really having a tough time actually figuring out how we... So, like, because the core advice, right? The core advice comes down to build RL environments, spend some fraction of your time reading papers, and then here's a blog post to tell you how to think about a lot of the things you're building, as well as the papers you're reading. But somehow something's getting lost in that. fewer contributors did speedruns of a few simple environments already solved, it would be helpful. Yeah, but like, so how do I get from there to helping people understand this stuff, right? Because I literally, all I do is I run puffer sweep on some environments, and like, hey, look, now we have some parameters so that when you press train, it trains fast. Like, how to use pufferlib, basics of how to use pufferlib are the docs, right? That's not how to learn reinforcement learning. Like, the key is that pufferlib lets you actually do reinforcement learning rather quickly while you're still learning some of the basics, which is not a thing that you used to be able to do. Like, you can basically build an environment. You can fix like some common error classes to get a sense for the problem. If I view this existing thing, which maybe I make some improvements to this, right? If I view this as like the general glossary, perspective, and stuff, what does this need for glue, right? Well, we could use some very small amount of math producing policy gradients, I suppose. What exactly you're trying to teach people? I'm trying to do an updated reinforcement learning guide. So reinforcement learning as a whole. So what I basically have here, right, is I have my old RL Quick Start guide, which upon looking at, the information in here is very, very good and is still all up to date. I just wrote, and this was by request, because normally I wouldn't write something like, I wouldn't write stuff for the real fundamentals like this, but I wrote a programming like guide, and I wrote an ML guide, general ML, general programming. I could have do this, understand this, right? Like do this, understand that. So I could say, you know, make a simple environment, understand these common class of errors. Okay, read this paper, understand this about the paper and about ML. And I could do that. That's probably the thing that's missing. People would appreciate a little step-by-step guide. There is a step-by-step guide for a very simple environment, right? Here's a very, very simple environment written in Python. Where everything is commented. And then here's the same thing in C. Commented. Live stream video. Structure of an Enver simulator. Torch.py. Okay, so there are two different things here, right? One of these is like, hey, can you make some like clearer content on Pufferlib? And another one is, can we have clearer content on RL? So I think that the thing that's probably missing here is like, how do I write a puffer env? It should be completely obvious if you already know other things in RL, and the thing is you don't. So it's like, for instance, if you know how Gym does its environments, which if you're in RL at all, you do, then like the puffer env format's pretty obvious from that. Because it's like just that with all the slow parts chopped off. It's pretty helpful, but most people ask. I guess, do I want to try to do this in isolation, though, is the thing? And puffer instead of RL. Then they can learn RL through puffer. Let me think how I can do this then. So let's say that I expand this guide, okay? Let's say that I expand this guide and I add, it's really only a few paragraphs, right? To just essentially explain some of the things that are in the comments of the files on how an environment is structured. the problem formulation and problem solving for RL, right? That's different from teaching people puffer. Okay, so let's say that I update this guide. You know, I kind of like the idea of having a few different articles, right, as resources, and then having a glue article where, like, this is how to learn reinforcement learning. It's like, are you new to programming in ML? Okay, go read this article and, like, do this, this, and this. All right, are you new? Like, cool, you've done that. Or you're like, you know how to program. Cool. You want to learn reinforcement learning. You're going to start by writing a very basic puffer environment to get just a feel for things. And I link you to a revised version of this article right here, or this doc right here, which could be an article. Okay? And that and the revised version will include the things that you guys are asking for. Just problem formulation plus puffer. It's a lot of stuff. I definitely want to improve this. Any plans to make it easy for people who just want to import instead of cloning? Not sure if it's been done yet. You can. There's a demo on this as well. Pufferl importable. Yeah, the problem is that if you want to, like, make your own environment, right, you have to compile it. And, like, it's annoying as hell to compile, like, C extensions for Python unless you're going to hook into the tooling of an existing package. Pufferlib. So you can absolutely use Pufferlib. You can use our trainer on other stuff, but if you want to build your own environment, it's still easiest to clone it for the sole reason that you have to compile it somehow. Okay, let's say that I'm going to start writing a little bit on the article. I'm going to update the docs for the tutorial to include, because, like, the thing that you're asking for like, the step function and that stuff, that's like 2 paragraphs. I can totally add that. Okay. I actually have some good ideas now on how we can do this. Use the restroom real quick, and then we'll do this. Whoops. Weird Python multiprocessing seg fault when sweeping. It's possible that your environment has a seg fault in it. Usually, it's that your environment has a rare seg fault. Yeah, you can compile with. It's a little tricky. So you can compile with debug equals true. Ideally, like what you should do is you should try to find a set of hypers or something that actually reproduces this bug. If you can get a single experiment where it happens within a few minutes consistently, you can compile pufferlib with debug equals true, and you can actually get stack traces. You can actually get where the seg fault is. Okay. Go here. 2 billion steps, lovely. Okay. Get rid of this. Make absolutely sure this is saved though. Hang on. It is. Okay. Now have this. Let's make sure. Yep, we now have this. It's 2K words. Good length. Hey Spencer. We got the general purpose article. We got a very good draft of this done. This is 2K words, programming and ML. And I'm starting on the main article now. And the hardest thing, and I spent a lot of time on this, is figuring out the format and like how I wanted to present information. I think I figured it out. Like all these other articles I have, they're like glossaries and like tips and general advice and such. And I think what I want to do is I want to have a main article that says do this, do this, do this, do this, do this, do this. Now you know RL, and it's going to reference all the other stuff that I've done. So I actually don't really need to rewrite my old RL Quick Start guide as much as I need to reference it and get you to do things around it. What effect does a good sweep have versus arbitrarily picking hyperparameters? Well, it depends whether you want your training to actually work or not. Target audience is to bring in new contributors, new just generally folks interested in reinforcement learning, bigger audience in general. Yeah, it's mostly just to grow Pufferlib as a platform and everything that we do. So hopefully these do pretty well. We'll see. The Petabyte article did incredibly well, and we got multiple new leads out of that on the business side, as well as quite a bit of interest on X. So, doing some work. What's a good counterpart to squared that would be super easy for someone to build? Not cart pole. Physics. policy gradient blog, I believe. Yeah, so this has the basics already. Yeah, this is fine. I should maybe make one of these. I could probably do it more simply, to be fair now. He's the RMS prop. Oh yeah. A few small things are dated. Binding, vec step, vec render, vec close. Should these always be called in the class that inherits from puffer? Puffer M to C, training speed up. So, those are the hooks into the C library. You'll notice that there's not really any logic in the Python files because the actual logic is in C. So you have to call the logic from C somehow. Oh yeah, the Pong thing. We make sure that this gives them enough information, like the readers enough information to like. When you make a new M, do you start with a certain template dir? Maybe ocean/template. Yes, that is literally what it is for. Copy paste that and then just change all the templates to your env name. In the quick start guide as well. I mean, not the quick start guide. That's in the docs as well. Counted reward. more thing with this. Let me see what else I want to give people at this stage. Before you write another environment. Okay, actually, I know what I'm going to do. Do I give them target or convert? I give them target. Oh, it's 4 p.m. already. That's okay. I'm in a good groove now. Yeah, so they just see a normalized distance to everyone. But where the hell do I give them a reward? Oh, here it is. Update goals. Okay, so resources for this one. Any other references I need to give people at this point? I want to give people hundred lines. Any other simple ones in here? Or yeah. Common screw ups. Do I have the common screw ups in? I'm gonna just add common screw ups. I'm just gonna make sure I do that in the blog. Right? Yeah, I'm gonna do wrong horizon to blog. So we'll just do long horizon box yep, data. Where'd all the tricks go? Yeah, so stuff. Okay. PPO have generalized advantage estimation as a description in there, or is it separate? Really big fan of Puffer. Good work. Thank you very much. I'm working on guide for beginners at the moment. More of a comprehensive reinforcement learning guide. They don't even have JE in here, do they? What software are you using to write this? It's just an X article. Yeah, they don't even have it in here, do they? So I gotta link both papers. Really liked Lillian's blog for a beginner's guide to RL. Oh yeah. Ah. This is too much math. Yeah, this is way too much math for this. Yeah, no, this is not what I would suggest. This is way too much math for this. Yeah, but you don't, the thing is you don't need this much. And this is not actually like useful math. Like honestly, one of the best things you can do in RL is completely ignore this MDP formulation of everything. It's dated and irrelevant. Bellman, like, kind of. Don't really need to know this up front. Honestly, the most important thing is even covered here. Yeah, Carpath. I think Carpathy's blog is way better than this. So yeah, this is the important bit here, the policy gradient theorem. Puffernet.h looks powerful but intimidating. Okay, so Tim, Puffernet is literally just for our web demos. It's not actually used for training. It's just so that we can put our tiny neural nets on the web because it's C, so it compiles to WASM. The blog that I'm going to recommend over this is Carpathy's old policy gradient blog by far. Pong to pixels, yeah. I'm writing this all up now. And by the way, this is actually in my current guide. It's just not in this nice form. So I'm kind of redoing. Is this real? What do you mean, is this real, Mike? How's it going? Tell us the secret to GPT-5. So what they did is they stuffed Sam Altman into a box, and what they did is they overclocked him dramatically. So whenever you're querying GPT-5, you're actually just asking a question directly to Turbo Mode Sam Altman, and he answers it personally. Where's your current guide? It's on puffer.ai, and it's also on X. We have a blog on puffer.ai. I gotta fix the top couple articles on there. Some formatting issues lately, but it's on there. It's also on X. Insanely locked in, you're typing fast without smiling. I mean, this is kind of chill day. I'm just writing some stuff. I'm normally building things. Guys, actual. Oh, that was a different startup. Like that was a different company that was actually doing that. I think that's happened a couple times. That's like I think that's actually happened a couple of times. I mean, it's basically like a Theranos but for AI, right? Kind of the situation. You integrate Google Analytics on Puffer AI. I don't think I did. Can you just go to like... No, I don't think I didn't do this on our site. Duck try to poach you? I mean, unless I've missed an email, no. What are you linking me? Oh. You need because you can track user behavior? Eh. Why do you like AI? I mean, I can build stuff that change the world from my chair here. It's pretty cool. It's like fundamental technological advancement of many, many things. Did skip C render in training mode? Yes. User have hard time find docs. I don't think it'll actually tell you that. Editor. I searched RL for like once yesterday and now this pops up. That's funny. I mean, it's cool to see that there's that much exposure, given that it's like a pretty small channel. It's a niche topic, so like there's not that much content out there. But yeah, welcome. I'm Joseph. I stream all of my research, so you'll mostly see me building new algorithms, new environments, applying RL to new stuff, all sorts of things. And then every so often I write articles and things on a little bit of the educational stuff, though it's mainly research. Currently experimenting with a bunch of RLMs. Each Atari M takes like 20 hours for one seed. This is why you use Pufferlib. Actually, let me just give you a quick little demo here, alright? Let me just show you why you use Pufferlib. Okay, Puffer, eval, Puffer, Pong. This is going to load up a untrained neural net. So this is a neural net that has not been trained. It's very bad, right? The blue one, it's losing. Yes? Okay. Puffer, train, Puffer, Pong. Do the elevator music. Just kidding. It's actually literally already done training. I just have to give it the latest model, which we just trained. And now you're playing Pong. That's literally all there is to it. So from however many hours it's taking you to literally 5 seconds. What algorithm? It is an enhanced variant of PPO that is the product of our own research at Puffer. How many GPUs you got? That just ran on my desktop here, which I'm also using for streaming. So 1. Technically, like probably 0.8 GPUs if the stream is taking like 20%. And you can see that we have like 25 different environments on Puffer.ai. Not all of them train that fast, but many of them do. How long would it take for vision-based? You'd be bottlenecked by the rendering, essentially. But I think that technically, you could probably... Actually, we have done this. I think you can do it in a few minutes if you really optimize, but it's a fair bit harder. How many GPUs do you have? Well, I have 20 overall, like in the background there. You can see I have a whole bunch of machines set up on those racks.
Hello.
Not much content's available about this topic. Is there any reason why? Is it an untapped topic? It's really hard. And if you check some of the stuff on Puffer, you'll kind of see why. So pretty much we've, like, right here, we've made the whole field 1,000 times faster in the last year. For context, my PhD is in multi-agent reinforcement learning. I've done a lot of work on speeding up reinforcement learning, different environments, different tools, things like that. And it's really only been since I graduated that I've been able to fully build this stuff. And essentially, like, I had to rewrite the entire stack of reinforcement learning to make all this work. And before I did that, like, if you look at any of the other libraries, everything was just really, really slow. It was kind of hard to get meaningful results. As the other fellow said here, it was taking, like, forever to do any basic experiments. Now you're just bragging? I mean, 20 GPUs is not a lot for research standards.
Hey, Joseph.
I'm trying to think. On you. Empirical side of RL is a nightmare. How many seeds, how many eval, not to mention hyperparams. We've fixed a lot of that. What if I'm making a new novel algorithm and I want to benchmark against PPO, DQN on a bunch of M's? How does Puffer there help there? So have you seen CleanRL? Puffer is not that much more complicated. You'd basically just take our trainer, you'd like remove the 200 lines of code that are actually PPO, and you would add your algorithm there, and then you would test across those two things. In practice, so Pufferlib doesn't work like other libraries, right? There are a lot of libraries that are devoted to just having all the algorithms. The thing is, they're all really slow and they're all really bad. So that's not what we do. We have our own algorithm that is just the fastest and the best. And we, like, as we develop more stuff on it, we test versus the old version of that algorithm to see if things have improved. What was your bachelor's? Computer science, AI. Same thing. I'm mainly using SP3 for everything. Okay, so Pufferlib is going to be both simpler and 1,000 times faster. Just like actually download it and try it. You can pip install it and you can literally confirm for yourself in like 2 minutes. Even CleanRL is slow. Yes, so CleanRL is also slow. You can think of Pufferlib as CleanRL but fast, while trying to keep things as simple as possible, understanding that, of course, it has to be a little bit more complicated in order to make it 1,000 times faster and support all the environments and all that. CleanRL is awesome. It's really, really nice overall. But, yeah, we just had to make it fast is all. Your algorithm better be a good one. I'll be an experiment around. SP3 has been a nightmare. My use case is to test my novel algorithm. Yeah, so I would just like go check Pufferlib, right? Pick some environments, run baselines, and then just make a fork and just do your algorithm there. Like, the code is really not that bad. Let me show you. It's a heck of a lot easier than SP3. I can guarantee you that. Okay, this is our entire trainer. It's 1,000 lines. The only actual relevant code for training is like the first maybe 300 or 400 lines. That's pretty much it. This is a standard PPO implementation, except that we have our, our innovations on top of it. So we've got this prioritized replay thing. We've got custom advantage function, a few other small differences. And then here's our eval loop. There's some extra lines in here because we do a bunch of profiling. You can make sure that everything is fast. And like we have some speed optimizations. But we really, really work hard to keep it simple. And I can guarantee you 100% that you will not find anything anywhere close to this speed, or anything close to this speed that's anywhere near as simple, or heck, you won't find anything anywhere near this fast in general. Like, this is faster than most of the JAX repos by a factor of 3 or 4 in literally PyTorch eager mode. I mean, you can see all the different agents that we've trained on here. Like Breakout, this trained in 30 seconds, beats the game. We've got Snake, this trains in like a minute. Plays Snake with a whole bunch of snakes. We've got Drone Flying, this trains in 30 seconds. Pretty much works out of the box as well, which is not a thing you see in RL. Probably replace my algorithm with PPO and try to run like 100 seeds. Yeah, so it's not quite PPO. Ours is better than PPO. It's going to be substantially more stable. You can absolutely do 100 seeds. We've actually gotten it to the point where like most of our stuff is very, very consistent. There really isn't that much per seed variance at all for almost all the environments. And we have like built-in hyperparam tuning. Welcome, Kovacs. Simplicity is impressive. Just really need a good step function with rewards, and Pufferlib handles LSTM and PPO. Yep. And it not only handles it, it handles it in a way that's very transparent. Like the entire training core of Puffer, right? It's about 1,000 lines for the train file. We have some default models that we use. So like a few hundred lines worth of default models if you want. And then there's like, I think maybe 500 lines of relevant code for vectorization. And that is it. That is the entire stack. So it's like all of reinforcement learning is maybe 2,000 lines. Doesn't have to be longer. Does Puffer support continuous action spaces? Absolutely. Really inspiring work. Hope to meet you at an A-star next year. A-star next year or so. I will be at RLC in a few weeks. I don't know A-star. Different conference? I know it's a search algorithm. Is there a conference called A-star? I do meet up with people. I will be in Palo Alto in a few weeks, followed by RLC, and I'll be back in Palo Alto for a bit. Oh, Yeah. So I've been doing less conferences lately. Like, I don't think I'm gonna do NeurIPS this year, because last year NeurIPS nearly killed me. I spent like 5 days in the hospital, lost 18 pounds with pneumonia. I'm still not recovered from that. Sucks. So I will be considering whether I do big conferences for a little bit. But I will be at RLC. How? Fucking just pneumonia, man. It sucks. I was in like ludicrously good physical shape as well. Like literally, I went to that conference having come off of run a 50K and then hit like a few weeks after that hit 1,000 powerlifting total, and then after that I hit like a pretty decent 5K time, and then it just freaking yeah, it's rough. Open review for last NeurIP submission. Heh. Was it the Neural MMO? Was it 3.0? No, what was it? Was it the Pufferlib rejected one? Underappreciated? Yeah. It's just academia does not appreciate this type of stuff. It's very ridiculous. But hey, it's fine. No, we will solve things. They will not. Yeah, it sucks, and I've kind of like in trying to train back, like in the process of trying to train to like get my old fitness back, I've kind of gotten a bunch of injuries. So it's like now I can't even really train properly, which sucks. So I'm working on all that stuff, but I definitely don't want to expose myself to giant ass conference again if I can avoid it for a little bit. Until I hurt my shoulder a month ago, I'd gotten my pressing strength pretty much back, and my deadlift is kind of close-ish to back where it used to be, I think. So I haven't really tested a 1RM lately. But everything else kind of just sucks. $2:30 here in India. Catch your next stream. Thank you very much for dropping by. I saw a comment, environments DM control so does not support an old commit buried. You asked if I supported continuous action space. The answer is yes. Can we add DeepMind control? Yes. If you look at any of the other third-party binding files, they're like super short and super easy. For the most part, they kind of just work. We haven't used DeepMind control in a while because nobody's asked for it, really. But yeah, you can absolutely do that. You might have to like make a 5-line change or whatever to make sure the latest version is bound. But like, we support continuous actions, and we mostly have a bunch of bindings for third-party environments. It's very, very easy to add your own third-party bindings for stuff we don't. Like, you don't have to do anything special, really, to make stuff work with Pufferlib. Like, we have one line, pufferlib.emulation.gymnasiumpufferenv or whatever. There are, like, several options. They're all very basic. No support, because, yeah, that comment is super old. We do have continuous action space support. Yeah, we do have continuous action space support, and we have it working on several different environments. Heck, I literally posted this. Here, I posted this yesterday. Oops. Or is it? Yeah, here you go. This is continuous action spaces. We did this for 4th of July. See the drone env? Oh yeah, Finn. So I did that. Finn and Sam made the original drone env. So yeah, we have a really cool new demo for drones now. It does more than just flag. Like, it can follow targets. It can do a bunch of different formations. And I came up with some like nice structured rewards for all of it as well. Did I get a chance to look at my question? Which one? Oh, the giant list of them? It looks like you pretty much want like a full guide to a ton of stuff, right? Yeah, so I'm going to add some material. I'm doing both, right? I'm going to add, there's a lot of material I got to add. Like, the thing is that, like, you're basically asking a whole bunch of questions on how to do stuff without asking how to understand any of the fundamentals, right? I can't really, like, I can't give you a robust template for how to do stuff that doesn't involve at least some level of understanding of the fundamentals. That make sense? Section of required environment fields. Nice. That's part of the template, isn't it, Tim? We have it like commented, like, you know, required, like, you know, make sure you do this way, etc., etc. The intent is that so you can copy the template, and then when you start editing stuff, you know what not to edit or like what to keep. How to think about them and use them. Yeah, so that's like API documentation, basically, about how the thing works, which we will include in the writing your own environment. What I'm going to do is I'm going to add that to the docs page, right? And then that's going to be one of the first things that like this sends you to. I'll build answers for all of them. Okay, how to understand an RL problem is going to basically what I'm trying to do, Maj, is I'm trying to sort of get you to build stuff and then slowly pull in resources. Like here, you're going to build a very simple environment. Okay, you're going to read some docs. You're going to build a very simple environment. Then you're going to read a blog post and a couple other things. And you're going to like train a different environment. And then you're going to build something a little bit more complex and read a little bit more, etc., etc. I've used Wannabe and Neptune, but compared to your works efficiently, my intuition would they could be slow and bottleneck. How do you handle logging millions of steps per second? Because you don't log every data point. Like you're logging. What would it even be on average? I think for Breakout, you're probably logging like 1 point every several million steps. So we handle all of that for you. Logging over epochs. Well, it depends. It's usually you log like once maybe every few epochs, I believe, or it's not every few epochs. I think it's time based. You log up like if it's been a certain amount of time since you logged the last point and there's data available, then you log it. But like a lot of stuff is averaged, right? Like you're not even gonna get the million log points into the trainer to then average and log to Wandby. Like there's already averaging that's happened before that in C. So like there are millions of log points in C. They're aggregated literally as you create them in C. And then the compressed versions are sent up to the main trainer, and then you have to like average a relatively smaller number of points across that. So we've done efficiency at very many different layers for you. The code's not that complicated and there's not that much of it. I don't like the sequencing of this. Yeah, this is a huge jump to reading your first paper here. I think you should build something. In making enms, if successful contributing, so going through your docs now. Env will probably be an ODE sys. Do you have other M's built? Numerical integration. You say the env will be an ODE sys. What do you mean? That the environment will be an ODE system. Like, are you trying to do something like neural ODEs, or like what are you doing? It is a nonlinear physics system. So step is often integrating the ODE is an initial value problem from 0 to t to get to the next step. Why is it integrating from 0 to t? I guess you mean 0 to dt? I don't know if you have a specific solver that you want to have, or you just want to like implement RK4 in C. Is there like a basic like RK4 in C? Want to implement? That would actually be very useful to us. Like if you wanted to actually like do something like this and like make it work in the context of an RL environment, we would be very happy with that. We really like when people with experience in other domains come in and do stuff that's not just games. Like our goal ultimately is to really advance a ton of areas of science. We suggest games because like most people that come in don't have experience in another branch of science, and games are like really easily interpretable, but that is actually the highest value thing for us. Yeah, I would just like from what I know, I would just do like a basic RK4. You can always do like an energy estimation to see if it's stable, right? If you're doing like, I don't know, some sort of physical system, you can just like can track energy to make sure it's stable. Just develop the env as a standalone in C according to our format. If you follow the guide, we suggest you kind of implement everything in C first, just in the way that we do it. make sure it works as a standalone like environment in C that you could interact with and see the dynamics working, and then you just plug it into our RL. Dopre 5. I don't know how good. Well, it depends on your it depends on how many steps of integration you have to take, right? RK4 is super fast, isn't it? Okay. It depends how many steps you have to take, doesn't it? What's the complexity of Dopre 5? Here's Dopre.c. This is gigantic, though. It really shouldn't be this long for an integration method. Oh, it's got a whole bunch of features and annoying things. I hope it's not this fancy. If it is, if it ends up being something this complicated, I would just start with RK4 and see if that's good enough. RK with higher accuracy, okay. Well, I just don't know how complicated the implementation is by comparison, or if it has higher compute complexity, right? So the key thing to know in RL, right, is simulation speed is absolutely king. So if you can get your simulation to run at like millions of steps per second, you're usually like you're golden, because you can just train on unlimited data at that point. So as long as you have a stable system that runs fast, you're usually good. I would definitely start with something simple, though, because as I'm writing in my guide right now, the price of complexity in reinforcement learning is very, very high. Errors are very difficult to catch because the agent can't tell you that its data is wrong, right? Or that some corruption is happening. And it's just going to, like, not behave as well as it should for some reason. How big is Pong? Oh yeah, Pong. what if you have a few different types of agents that need to train models for? Also, what if you want an agent to be able to take an action every 100 steps? Why would you do that? So if you have a few different types of agents that need to, you can usually just train one model. I've done this all the time. It's fine. As long as you can make the obs and action spaces match, kind of fine. If you want an agent to take an action every 100 steps, it's probably going to be pretty slow. I don't know why you would do that, but you can. It's just that the step function takes the action and then it updates the end 100 times in a loop, right? You just better have fast dynamics if you want to do that. If you're simulating an economy where you have manufacturers, warehouses, and storefronts, the manufacturer decides once a season to make. RL is not a fun thing to do in a low data regime. So if you have a sim that runs really, really fast, you can do this. But if you're gonna get if you're not gonna get that much data on the results of your actions, and it's gonna be really delayed feedback at that, it's not gonna be a fun time. Use RL for high data regime problems. And if your problem isn't high data regime, ask how you can make it such. Right? Make it so. Is it fair to say if you had a system where you had to control 10 gauges, build a model with all the gauge chaining options in the action space, rather than trying to make each gauge an agent? Yes. It's just a box of 10 or a multi-discrete with 10 options. What's the difference between vecnumEms and envnumEms? So envnumEms is in a single so it's only this case for ocean. So only our RC environments do it this way. EnvnumEms tells you how many copies a single process is going to simulate, because the individual Python class can actually create like 4,000 environments or whatever sometimes. Okay, and then the vecnumEms is going to tell you how many processes. Instead of spawning 8,000 processes with one environment each, you're going to spawn like 8 with 1024 environments each. We have other ways of doing this as well for like slower environments with serial, because like you can technically do the same thing a bit differently, but this is the fast way of doing it. Okay. I will, I think this is probably going to be like a 10-parter, like a 10 section. Let me just see if I can write these real quick. This is going to be like here. Be like, Puffer, Algo, article, etc. And this is Flutter research. It's going to be something like this, I believe. And this is pretty well the full path to becoming a competent researcher. Obviously, like, you have to repeat the last few of these several times. But this is quite good, I'd say, overall. Okay. It is 5th of July. Huh. Kind of cool. So apparently AI training computer expenses are going to qualify as R&D. That is very nice. That was a whole bunch of writing. Usually there will be experiments and research around here, but I figured that I would work on something for you guys. Need to finish this. Need to update the docs, the extras that we discussed. This is well on its way, though, I would say. This is very well on its way. We'll have this. We'll have the programming in ML guide. We have all the other articles I wrote for 3.0 and Spencer wrote, like all the different things. We've got a pretty dang good base of content. We'll just have to figure out sort of how I want to organize it and what things are going to go on the website and all that. Okay. Thank you for tuning in, folks. I'm going to dinner. If you want to support all this work for free, just star the repo. Really helps. Get involved by joining the Discord. It's free. It's freely available. There's no invite link. I mean, no invite code, just link. You can follow me on X for more. Thank you, and I will see you around.